Hi, I'm Reverend Greg and I welcome you to this video in this tutorial series Shaders for Hobby Programmers. Today we're going to create another distortion shader. This time it's going to be the Shockwave effect and we're going to do this with a normal map. If you don't know what normal maps are and how the normals are stored in RGB values, you can watch the previous video in this playlist called Normal Maps for 2D Games. A link to the playlist is in the description of this video. But as always, a short disclaimer first.
This tutorial series is mainly for hobby programmers who struggle with understanding shaders. I'm not a professional programmer and I'm not very good at maths, so if you see any mistake in my video or see a better way to solve a problem, please add a comment so everyone can learn from you.
Let's start with a short overview of what we're going to do. I'd like to be able to draw several shockwaves at the same time, so we'll need a data structure to keep track of all waves. In Create Event, we'll create a list of waves, and that's our master list. Each entry in this list will describe one active wave. And in Step Event, on click, we'll create a new wave. The new wave is a list as well, and it'll store wave parameters like its position in the game, its age, which starts at 0, its lifespan, in this case 100 steps, its current scale factor, which again starts at 0, its maximum scale factor, in this case 3, its alpha value, which is going to affect the distortion strength, it'll start at 1, and its sprite. Once the parameter list is filled, we'll just add the list ID to the master list. Now in the demo, each wave will have the same lifespan, max scale and sprite, so we'll use less wave parameters. I just showed them here anyways because in a real game I'd probably do it like this. Also in Step Event, we'll iterate through all waves in the list of waves, increment the wave's age, and recalculate the current scale factor and the alpha value. Or, if the wave has reached its lifespan, we'll destroy it. So here we got one active wave in the list of waves. The rectangle on the right side is the screen, and the wave was created 80 steps ago and has 20 more steps to live. It's scaled up quite a bit already, and it's very transparent already, so it won't distort a lot anymore. And 40 steps ago this wave was created. It's not as old, still has 60 steps to go, so it's not as transparent and not as large yet. Also it's using a different sprite. And this wave was created only 20 steps ago. It has much longer to live since its lifespan is 200 steps instead of 100, and since its max scale is not also twice as much, it'll grow slower than the other two waves. So this is how we'll store the waves with their parameters. Now let's have a look at how we're going to draw them. There's lots of ways to do this. Before trying out normal maps, I experimented with sending the application surface and all wave data like position, radius, wavelength and amplitude into a distortion shader, calculate the distortion based on that wave data inside the shader and draw the application surface distorted to the screen. It was difficult to create different wave shapes and I wasn't happy about performance on mobiles, especially when showing more than two waves at the same time. Then I tried using a texture ramp instead of amplitude and instead of other wave parameters to describe the wave's shape, but I was never happy with the performance and the looks either. So I finally tried using normal maps and that was much easier and more flexible. It's a bit slower if there's only one wave, but much faster with multiple waves, and it's always very flexible regarding the wave's shape. So here's what we're going to do step by step. We'll need normal maps to describe the wave's shape. In this case, it's a simple ring shape. We're going to create a wave surface and clear it to RGBA 0.5/0.511. That's a normal color for a normal vector pointing straight out of the screen. Then we're drawing the wave's normal map to the wave surface like this. But if we draw multiple waves, they would erase each other. So we need a way to blend the waves, and we can't just add because that will completely change the normal's vector. So we're going to use the extended blend mode destination color, source color, to blend the wave's normal map with the wave surface. This will kind of preserve the normal vectors. But I also wanted the wave's distortion strength to fade out over time, and to do that we're going to draw the normal map with decreased alpha. A new wave will be drawn with alpha 1, and the older wave is, the lower its alpha value will be. You can see that on the wave surface image. The newer, smaller waves look strong, and the older waves are fading out. And to get the alpha fade to work correctly in this blend mode, we'll need a very simple shader to add those normal maps correctly. Actually, this result is not absolutely correct. If you look closely, you'll notice the normals get too bright or too saturated where the waves overlap, but for this effect, I think it's good enough. Now we're going to distort the application surface as a post-processing effect. So in post-draw event or any draw GUI event. In this demo, we'll use the draw GUI begin event. We'll set the Shockwave Distortion shader, draw the application surface, and pass the wave surface into the shader as a second texture. The Fragment Shader will read the normal color from the wave surface, use the normal vector to calculate a texture coordinate offset, and then take a sample from the application surface at VV text chord plus that offset. It's quite simple if you know how normal maps work, but it isn't if you don't. In the latter case, just watch the previous video in this playlist. We will add an optional effect as well, a chromatic aberration, but for now let's have a look at the project file. We won't need much for this effect. There's two sprites here, sprite Shockwave Distortion normals 64 and 256. We're going to use the 64 pixels version, but I left the larger version in there just in case you want it. Each has the same 10 sub-images, and we will use those sub-images as distortion maps. They actually wouldn't need to be square, and they can be on mixed texture pages, but their origin should be centered because we're going to scale them. Then we got two shaders, one to add the normal maps to the wave surface, and one to use that surface as a distortion map. And here's the room. On the background layer is a mockup game, and on the asset layer a mockup player character. Both assets were created by an artist spelled pzUH. No idea how that's supposed to be pronounced, but I left a link to his or her OpenGame art site in the description of this video. Then on the tile layer is a standard grid tile set. On the main layer is the Shockwave Distortion object, and on the GUI layers are the demo project's GUI elements. For this demo we'll need 3 sliders to simulate game speed, to set the distortion strength, and optionally the aberration strength, a toggle group with 10 toggle buttons to select the distortion sprite's subimages, a second toggle group with 3 toggle buttons for debugging. This will allow us to overlay the wave surface, a toggle group with just 1 button for debugging as well, and this will toggle between showing either the mockup game or the grid tile layer, and allows the debug toggle to display the wave parameters like age and scale of all active waves. And finally, there's the Shockwave Distortion object. Let's just look at the generic demo project stuff in the create event. In the title region are just descriptions for this demo, unimportant for the effect to work. And the same goes for the GUI region. Here I'm just setting up the GUI elements, the 3 sliders to change the uniforms, and all the toggle buttons to set the debug features. The important stuff is in the sprite and shader region. Here I'm setting the sprite variable to the smaller of the 2 normal map sprites I showed earlier, and then we're setting up the distortion shader. Effect strength will or increase the general distortion strength of all waves, so it could be a constant inside the shader code instead of a uniform. We're going to apply the distortion when drawing the application surface to the screen. Its coordinate system will be squeezed because the application surface usually isn't square, so we need the aspect ratio to adjust the normal vector. In the end, we'll add a blur or chromatic aberration effect, so we need an aberration strength. Of course, this could be a constant inside the shader instead of a uniform as well. And finally, we'll need a handle to send the wave surface texture ID into the shader. The next few lines are the wave parameters. As mentioned, in this demo, wave life and scale max are the same for all waves. I've set the lifespan to 1.5 seconds, and the scale max factor so the normal map will scale up to 1600 view pixels. And for the individual wave parameter list, I've prepared an enum for position, age, scale, and alpha of the waves. Then of course we need to create the list of waves, the master list. We also need to prepare the wave surface. Surf waves will be the surface ID. Surf waves scale will set the size of the surface in relation to the view size. The surface doesn't need to be as large as the view, and thus we can, in example, set it to 1/4, like in this example. And of course we need view width and view height. And since we're creating a post-processing effect, we also need to disable the automatic drawing of the application surface. Now with everything prepared, we can go through the code step by step. First we'll need to create, update and destroy the waves, and all this happens in the step event. To create a wave, we need a trigger, like a collision or such. In this demo project, it's just going to be a mouse click. So whenever the mouse is clicked, while not on a GUI element, we'll create a new list to hold the new wave parameters. Then we set its X and Y position to the mouse position, its age to 0, its scale to 0 as well, and its alpha to 1. After that, we'll add the new parameter list ID to the list of waves. The second code block in the step event updates the waves. We'll just get the size of the list of waves to check how many waves we currently got, and if we got more than 0, we'll iterate through all waves with a for loop, get each wave parameter list's ID from the master list, and advance its age. Usually we'd just increment age by 1, but in this demo, to be able to slow down, I increment age by slider 0's value. If the wave has not yet reached its lifespan, we'll calculate its scale and alpha. I've used custom tweens here instead of lerps because I didn't want those factors to change linearly, but basically we're just comparing the wave age with the wave's lifespan to see how many % of its lifespan is passed. To get the current scale factor, we can just multiply the tweened age percentage with the max scale factor, so scale will start at 0 and go up to whatever max scale is. And to get the current alpha, we'll just subtract the tweened age percentage from 1, so alpha will start at 1 and end at 0. Now if the wave list has reached its lifespan, we can destroy the list with the wave parameters and delete its ID from the master list. And since that decreased the master list size, we'll also need to decrement the loop counter and the list size variable. The last two lines in step event are just for the demo. Toggle button 0 in toggle group 0 will set the visibility of the grid tile layer, so when running the demo we can toggle between distorting the grid layer or the mockup game. In cleanup event I'm enabling the automatic drawing of the application surface so other demo rooms work correctly. Then I'm destroying any wave parameter list and the master list to prevent memory leaks and free the wave surface. So that's all about creating, updating and destroying the waves. The next step is creating the wave surface and drawing the wave's normal maps onto it. Since it's a post-processing effect, the draw event is empty. I decided to use draw GUI begin event, but you could do this in post draw as well. First, we'll check if any wave needs to be drawn, and if not, we're just going to draw the application surface. But if any wave is active, we'll apply the distortion effect. To do that, we first need to get the slider values. For now, all we need is the local var subimage selected by the toggle button group 2. In this demo, we're going to use the same normal map for all waves, and that toggle group allows us to set which normal map to use. Then we need to check if the wave surface already exists. If not, we create it and store its texture ID. The size of the wave surface is view size times surf scale factor, which we had set to 1/4 in create event. Then, for a smooth result, we should turn on the GPU's linear texture filter, and now we're ready to draw the wave's normal maps to the wave surface. Set the surface and clear it to RGBA 0.5/0.511. Then set the blend mode destination color source color and set the shader to add the normals. We'll look into the shader in a minute. Once that's set up, we'll need to iterate through all waves as we did in the step event. We'll just draw each wave with its parameters. The sprite is the one with all normal maps and the subimage is the value we got from the toggle group. The position is the wave's X and Y center in room coordinates. But since we're drawing to a surface, we need to subtract the view's position, and since the wave surface is scaled down, we also need to scale the coordinates by the same scale factor. In step event, we constantly increase the scale of each wave. The older it is, the larger it gets, so the sprite scale should be the wave scale times the surface scale factor. The rotation is 0, the vertex color is white, and the alpha is the wave's alpha, which we decrease each step in step event to let the wave fade out over time. With the waves drawn to the wave surface, we can reset the shader, the blend mode, and the surface. Now let's have a look at the shader used to add the normals. The vertex shader is just a pass-through shader. And as you can see, this fragment shader is very simple too. All we're doing here is getting the normal map's color, mix it with RGB 0.5/0.51, and the mix amount is the vertex's alpha. The older the wave is, the lower its alpha is, so when the wave is created, its alpha is 1, and thus the output RGB of this shader is the normal map's color. But with increasing age, the alpha is decreased and thus the output RGB is slowly turning into light blue. And since we're drawing in blend mode destination color source color, this will kinda look like combining normal maps. Mind the output color's alpha value needs to be 1 for the shader and blend mode combination to work as intended. And with this we created the wave surface. Now on to step 3, distorting the application surface with the wave surface. We need to draw the application surface to the screen and use the wave surface as the distortion map. Let's continue with the rest of the draw GUI begin code. Up here we have to get 2 more local vars from the GUI sliders. Effect strength is a distortion factor for all waves and should be a rather small value. In this demo it's only -0.1 to +0.1. And aberration will set the aberration strength, so something from -1 to +1. With those 2 values, we can now set the distortion shader, pass in the uniform's effect strength, aspect ratio and aberration, pass in the texture ID of the wave surface, draw the application surface and reset the shader. And for this demo, I'll also reset the GPU's linear texture filter. The rest of the code here is just for debugging. With toggle group 1, we can set if the wave surface should be drawn as well. The options are either no, yes, scaled to fill the screen, or yes, but only as small as it is. And with toggle group 3, we can set if the wave data should be drawn as well. You'll see what I mean when the demo is running. Now the distortion shader. The vertex shader is just a pass-through shader, and this time without the vertex color even. The fragment shader is quite simple as well. Like in other videos, we'll look at the essentials first and then add some things. So in the header, the essentials are the texture coordinate of course, the effect strength, the aspect ratio, and the wave surface texture ID. Inside the main function, we first need to get the texture coordinate offset from the normal map. Again, if you don't know how normal maps or vectors work, watch the previous video, it's explained there. For this effect we'll only need two components of the normal vector, the x and y component. So vec2 offset is based on the normal map's red and green value. Subtracting 0.5 and multiplying by 2 will turn that into a normal vector, and multiplying the result by effect strength will scale the vector down to a magnitude reasonable for a UV offset. Then, to adapt the offset to the stretched UV coordinates of the application surface, we need to divide offset x by the aspect ratio. All that's left to do is get a sample from the application surface at a VV text chord plus offset and set the output GLFrag color to that sample. Everything in between is commented out and is just for effects we'll add later. So you can see this shader is actually extremely simple. All the tricky distortion math is replaced by the normal map. So let's run this. Clicking now creates new waves. On top you can see the parameters of each wave in the list of waves. And toggling the debug functions, we can overlay the wave surface as large as it is and stretch to the screen. We can also remove the info text and switch to the mockup game to see how the shockwaves look there. And we can change the shockwave subimages with these toggles. The cube ring is a good example to show that using small normal maps and a small wave surface sometimes doesn't work well. This will look better if the map and the wave surface would be larger, because when scaled the cube edges just look too jagged. But the flower map is a good example to show that the small size of the map and the wave surface can work quite nicely. Now, one thing that could look wrong in a game are the borders. In the example I hid here behind the GUI, you can see how the last row of pixels gets stretched. If the shockwaves are fast enough, that won't matter, but let me show a quick fix anyways. A simple solution would be to replace everything that's stretched with a solid color. So back in the Fragment Shader's header, I defined a vec3 border color macro. And just before outputting the color, I added some code to determine whether VV text chord would be outside the surface, and if so, replace the outcome color with the border color. I try to avoid if statements because they're rather slow in shaders, but I'm actually not sure if creating another float and stepping twice is faster. Now let's run this again. Of course this might not be perfect, but I still kinda like it. The next addition is an aberration. First, just a simple blurring aberration and then a chromatic aberration. So we'll need a uniform aberration now. And instead of taking one sample at VV text chord plus offset, we're taking 3 samples, add them up, and multiply the result by a third to compensate the brightness from adding colors. The first sample is taken at VV text chord plus offset. The second sample at VV text chord plus offset times 1 minus aberration, and the third sample at VV text chord plus offset times 1 plus aberration. Now let's run this again. I think blurring really adds to the effect. And with the aberration uniform, we can set the effect range. Now let's turn this simple blur into a chromatic aberration by multiplying the second sample with magenta and the third sample with cyan. Mind that we can't just multiply the result with 1/3 anymore. We need to make sure that the color value is preserved. If you don't know how this works, watch the tutorial about the magnifying glass effect a few videos ago. The chromatic aberration was explained there in detail. And now let's run this again. We now got a nice chromatic aberration effect. I don't really think this looks better than the simple blur or the plain distortion versions from earlier. It's just about what looks best in your game. I've also added a chromatic aberration with orange and blue, and this is what it would look like. So that's it for this video. Once again, I really hope you liked this effect and the decision to use normal maps instead of maths to distort. In the next video, I'm going to show how to create normal maps for 2D games in the 3D software called Blender. The sphere, the cube ring, and the meta ring in this demo were created that way. I'm probably not going to show how to create the other normal maps from this video because it's not worth a video. Just create a grayscaled image and turn it into a normal map in GIMP, Photoshop or online. Until next time.